This is just to help you when you go over the memo, just to clarify how I marked some things. Sorry, I've just done it in a hurry, so the when I uploaded it to the explain everything, the pictures moved. But just if you look at this question of the motor, okay, so we helped you a little bit because the one thing said there was a fixed brush, but when you labeled Y, that's not just a brush, it's a carbon brush. And then just be careful that you don't get confused between slip rings. Okay, that's got a gap in it, so it's a slip ring commutator. Also, just be careful, some of you are a bit confused about question 1.2.3. Remember, each side experiences a force, so you had to use Fleming's left-hand motor rule on each side of the coil, and you'll see that the current's going up on the side of CD and down on the side of AB. So you wanted to then say what force it was experiencing on each side, so either up or down. And then just to keep the coil moving, you need the split ring commutator. So just be careful, take note of the wording. Okay? It's to reverse the direction of current in the coil in each half turn. So that's the key words that we were looking for. And also, some of you just said use a bigger magnet. Okay, it's not a bigger magnet, it's the strength of the magnet. So it's the strength indicates strong, greater magnetic flux. And then the other questions were really well answered for this question. Just for this question on the coil, you'll see later on in the slides, I've done the answers on the answer sheet. But so this is electromagnetic induction. So you had to use Lenz's law. Please just note, was a bit generous in the laws, and I gave you 1 out of 2 if you didn't 100% correct. But remember, in trials and in the final exam, if you've left out some key words, you'll get 0. So a lot of you left out the word the current flows in a direction as such, so that the magnetic field opposes the change in magnetic flux. So just take note of that. So you must just label the side that's closest to the magnet is going to be a south pole, and the one that's furthest away is going to be a north pole. Then you use your right-hand solenoid rule, and you stick your thumb in the direction of the north pole. A lot of you didn't label the current as it's coiling around and coming out. Okay, you needed to show that direction, so that's why you just got 1 out of 2 for that question. Okay, again, for Faraday's law of electromagnetic induction, if you left out the word rate of change, you only got 1 out of 2. The physical quantity is not the rate of change. Okay, physical quantity is the EMF, so that's why you got 0 out of 2. And then revolutions per minute, you need to pay attention to the units on the x-axis. The time was in milliseconds. It took 40 milliseconds to complete 1 revolution. So 40 milliseconds, you divide by 10 to the minus, to divide by 1,000, or times by 10 to minus 3 to convert it to seconds. And then you say 60 divided by 0,004, you got 1,500 revolutions. So some of you are on the right track, but have got 150 because you didn't convert. Remember I said pay attention to the units on the x-axis. Okay, the one on the oil pipeline was actually well done. So I think most of that is self-explanatory. Okay, again, this question on the generator was well done. Just remember the position when it's 3/4 of a cycle is in the vertical position, so it will have a minimum EMF. And then the purpose of the slip rings, I know that you probably taught that to prevent the tangling of the wires. Yes, that's a practical consideration. And I did give you 2 marks if you said that. But it's actually not the main reason why we have slip rings. The main reason you have slip rings is so that you keep the direction of the current in the external circuit the same as the coil, which results in alternating current. You wouldn't get alternating current if you didn't have the slip rings. And then please don't come and tell me that you wrote the wires are tangled and you got 1 out of 2. If you said something incorrect first, and then I gave you 1 out of 2, even though you should get 0 out of 2. And then the total of the test I just made out of 43, because only after marking the whole test did I realize that question 1.1.1 was out of 3, and I marked everyone's out of 2. And question 1.2.4 was out of 2, and I marked everyone out of 1. So instead of going back and remarking everything, I've just reduced the total out of 43, which is actually to most of your advantage. And those of you who prepared thoroughly did really, really well, so well done.